So hi again. Today's problem is combination sum 2. The question states that you are given an array. You have to generate all the subsets and the sum of the subset should be equal to k. You have to return those subset only whose sum is equal to that k, and also there is some condition, that is you have to return all the subset into non-decreasing order, basically increasing order, and you have to keep in mind that all the subsets should be unique. Means you cannot have duplicate subsets. So that is the question, and we will go to the discussion part. So to make all the subsets, what can be the approach? Basically, we can either include one of the elements and we can either exclude that one element, right? Means we can either take one element or not take it. So for each element, either we can add these two into our answer or not. Means for this position, there will be two number of combinations. There will be two, there will be two. So both will be multiplied, and that will be 2 to the power 3, that is 8. Basically, for n number of arrays, that will be 2 to the power n number of steps to generate all the subsets. So one thing is clear, that this approach will take 2 to the power n, basically exponential time complexity. And another one is clear, that we have to use recursion. Basically, you have to use recursion. Why? Because you have to you have to access all the possible ways, and recursion will be better approach. So let us try to draw the recursion tree at first for these 2, 3, and 3. Okay. Initially, our sum will be empty. We will not consider any of the elements. Now let us start iteration. First of all, our I position will be here. Now either we will take this two or not take it. So for the left hand side, we will consider it. For the right hand side, we will not consider it. Then again, for 3, 2 will be there already, and 3, there will be 2, there will be 3, because we are considering 3, there will be none. Again, we will consider another 3. So basically this 3. Now 2 and 3 as it is. Now we can consider 2 and 3. Also, there will be 2 only, and there will be both 2 3s. There will be only 1 3. There will be last that 3, and there will be null. So that will be our recursion tree. And now I am drawing this like level order, but thing will be not like that. Basically, it will be like DFS. First of all, we will consider 2, then 2 3, then 2 3 3, and then backtrack, and again 2 3, and backtrack, then 2, then 2 3, like this way. So now observe one thing. These are the base case or leaf nodes. Sorry, my mouse is okay. So this this will be the base case. This one, this one, this one, this one, this one. Perfect. So if we sum up these elements, then we can get the answer, right? Means for here the sum will be 8. For here sum will be 5. Here 5. Then 2, then 6, then 3, and then 3. And how many leaf nodes will be satisfied to the k? That is 2. These two. These two leaf nodes will provide us the sum of value of 5, that is equal to k. This is the k. Okay, so one thing is clear that we can now somehow manage to get all the subsets that the sum of the subsets will be equal to the k. Now, as I said, there will be multiple subsets, but we will consider one of them. Means we have to consider one of these, either 2, 3, and these 2, 3. So you just think what can be the data structure that can be implemented here? Set, obviously, because set will store only unique elements, but the interviewer will not be happy to uh, when you will use set, right? So let us think something different. Look, we cannot optimize time complexity so much because it will already take 2 to the power n. So forget about the time complexity. And what we can do, uh, we are not using set, right? So what only one approach there will be. Suppose you are not always given the array in the sorted order. This arrays can be like this. So observe one thing. If we sort this array, that will be 2, 3, 3. And we are calculating all the parts, right? Now, when you are here, will you consider this 3 again? Because this both 3 are same. And why I am talking about the sorting? Because sorting helps us to uh, combine all the same elements together. Suppose there is 2, 1, 1, 1, 3, 2. If we sort this, that the answer will be 1, 1, 1, 2, 2, 3. Now look, all the same elements are closer now, right? So it will help us to check either these three elements are same or not. Yes, and then we can only choose this element or not. Suppose there is 1, 2, 3. Then we have to check all the elements. But there is 2, 3, 3. Then we will check one of them. So to check the two number are same, we can use sort, and then this two number will come closer, and iteration will be easier, right? So that's why we are using sorting. Now let us go back to our example and how to check the two elements are same or not. Okay, where is my eraser? Got it. Nice. Now let us draw the recursion tree again. Initially, the sum will be empty. We will take 2, then 3, then 3. Now, one thing is sure that when we are taking the elements in the first time, there cannot be done anything because we have to at least check once. Okay, so now this is the best case. We will go back here, and when we will go back here, the I position will be here. Now, we will make another variable here and check those two variables are pointing to the same position and the elements are same. Then we will move this A to the right hand side. Basically, we will increment the A. So here A and I will be pointing to the same position, that is 3. So we will move A here. Again, both are same. Yes, obviously. So we will move A here. Now this is out of bound, right? So we cannot further call any recursion. So we cannot go there. Okay. So backtrack again. Now to AC. The pointer will be here. Let us erase this A also. This A, this A, this I. Okay. So I is here. A will be here. Both are same? Yes. A is now here. Both are same? No. Now we will consider these three. and go to the right side. For the right left hand side, when we are taking, there is no option, so we have to insert 3 also, and we are backtracking. And for the right hand side, for the right subtree, then we will check this condition. Let us erase at first. And okay, so where's my pen? Yeah. So after putting these 3, we will backtrack and put I here and check A will be here. Are those same? Okay, so move A here. And are those same? Yes, move A here, and cannot move there because A is out of bound. Okay. So now observe one thing. Uh, Here will be the our leaf node. This is our leaf node. Let us sum of all the values, and that is 2, 3, 3. That will be basically what? 8. And here that will be basically 2, 3, 5. Okay, let us use another color. Here 2, here 6, here 3. So now how many 5 will be there? Only 1. So that's how we can iterate this recursion tree without having duplicates. So that will be our answer. Now let us make the pseudocode. The base case will be clear when the I pointer will cross the n, we will stop. And another base case will be when the k will be 0, means if you are making your code optimized, then you can take that k and divide the current position, current element. And when the k will be 0, then you can understand that, okay, so you are making the sum already. So the k is now 0. So that is a positive base case. This is a negative base case. And also, if the k is less than 0, then we will simply return. That is also a negative base case. So in only this position, we can put our answer vector into the 2D matrix that will be sent by us. This will be the base case. And for the take and non-take side, look, the taking part will be so easy. Basically, we have to insert the particular element into the vector and then call it. Then call it. Uh, we will see how to call it properly in the code, and then we will again remove that element because we are backtracking here. And then we have to check why is my okay, now it will be easier. Actually, I am writing using mouse. So after taking part, the non-take part will be like this. Is it too small? Can I zoom it? No, sorry, I cannot zoom it, I guess. Okay, not a problem. Let us continue. And yeah, for non-tech, but what can we done? Basically, we will run a while loop, and also there that is the a. Can you remember that a? We will make that a variable. A is equal to idx, and we will use a while loop. Basically, what we will do until we are getting the same elements, we will increment the position a. So one condition will be I less than uh, basically a less than n, and another condition that is a array of a equal to array of idx. So until this thing satisfies, we will just increment a and then call it. So for the calling part, that will be, let us think out a solve function, and there will be array, the sum that will be not here. We will not consider that variable. So the sum will be same. Basically, the k will be same, and we will send the index that will be currently a. Yeah. So we will send this kind of things. And for non for taking, we will just use solve. Array will be there, k minus array of idx position, and obviously I plus 1. Why I plus 1? Because we are considering that element. So we are considering I plus 1 because we have to move forward, right? So that will be the overall approach. Let us try to code it up. Let us go back to the console. Okay. Now this is a time to make the answer variable, answer vector in answer, and another vector that will store the temporary values in game, and we have to sort the initial vector, sort dot begin error dot end. Okay. So now we can make another function that will help us to get the answer, that will be solve as it is. We will pass n minus 1 as index. Okay, no, we will take 0. N minus 1 will also work, but we have discussed our theory by using n is equal to 0. So 0 will be better. And k, and then what we need, answer and temp, return answer. Fine. Let us make the solve function, void solve vector in answer, sorry, array. Okay, so we are now passing the reference. It will help us to save the space, and int idx, sorry, int k, vector in answer, and that will be also passed by reference, and vector in temp. Okay. So what is the best case? If the k is equal to 0, then simply we will put the value into the answer vector and start push that temp, and we will simply return. Another best case, if k is less than 0 and idx is equal to or greater than n, then we will stop. Fine. Now for the tech part. What will be the tech part? Basically, we will include that current position element into our temp, and that will be uh, array of idx. Then we will call the solve function again, array index plus 1, because we are moving forward, and k minus array of idx. Why? Because we are taking that element, so we have to reduce it or subtract it from the k. That's how we can make the k 0, and answer and temp. Very good. Now let us remove the last element because we are using backtracking. Now come for the contact part. Now, as I said, we will make another variable that will be a. and that will point to I, basically IDX, while A less than N, and array of A is equal to array of IDX. Then we will increment A. Okay. So then we will call the solve function again for the non-take part. Array for IDX position we will pass A, our new position, and K will be as it is because we are not considering that element, and answer and temp. Fine. Okay, so we have completed our coding part. Hopefully everything is right. Let us uh, okay. So let us compile this code. We are getting error. Why? Uh, why? N was not the, oh, sorry, we did not pass N. Okay, not a issue. K here, N 10, and also you have to pass here, and here. Let us run again. Again, another issue. Uh, where is the issue? Where is the issue? Oh, sorry. Have I done right here? Yeah, fine. So answer is coming fine. Things are matching. Let us submit the code. Great. This working. So basically this is the approach. And for the time complexity, obviously 2 to the power n, and the space complexity that will be n for the auxiliary stack, and the temporary temp for this temp vector. And yeah, so this is the approach. Hopefully you have understood everything clearly, and thank you. Signing off. Bye.